Alright, let's look at the practice exam 2, problem number 8. Alright, so we want to find the point on the graph of y equals square root of x. So this is a graph right here. Right, that is the closest to 3, 0, so which is the point right here. Right, so since we don't know where on the graph, so I'm gonna just call it this point x, y. But since we at least know that this is going to be on this graph, y is the same thing as square root of x. So we can actually write it as x comma square root of x. Right? So you have a point 3, 0. Right? So you have 2 points. We can find express the distance using the distance formula. Right? So let's think of this as x. This is as x2 and a y2, and this is x1 and a y1. Right? Then let's find the distance. So distance d can be expressed as square root of x2, so x, minus x1, 3, quantity squared, plus and y2 square root of x minus y1 0 squared. Right? Then if you simplify that, you're going to get the square root of, right, so you have a x squared minus 2 times 3 times x, so 6x, but you have another x from here, so negative 6x plus 1x, so it's a negative 5x, and the 3 squared would be 9. Right? So we want to minimize this distance, but in order to minimize this quantity, all you really have to do is minimize this inside function. So we're going to actually try to minimize function f, which is the inside of this square root. So you have x squared minus 5x plus 9. Right? And so we want to minimize on, so anywhere, so x starts from 0, and you can I guess go as far as you want. Right? So let's try to minimize this quantity. Right? So we take the derivative, and which is going to give you 2x. Derivative of negative 5x is negative 5. Derivative of 9 is 0. So we set that equal to 0. So we have add 5 to both sides, so you have a 2x equals 5, and then we can divide through by 2, so we get x equals 5 halves. Right? So this is our critical number. Actually, there's only one critical number here. Right? Then just draw a number line to make sure that that's going to give us the minimum that we want. So here is 0, and you have 5 halves is right here. Oh, 5 halves. That's what I meant. 5 halves. Alright, so let's look at the sign of f prime. Right? So we can try like 1. So if you plug in 1, 2x, 2 times 1 minus 5 is negative, so we have a negative sign here. Right? And try something bigger than 5 halves like 3. Right? 2 times 3, 6 minus 5 is positive, so you have a positive here. Right? So you have a decreasing turning into increasing, so we know that the first derivative test, we know that this is going to be the minimum that we're looking for. Alright, so the closest point, so x coordinate is already have, so 5 over 2, and y coordinate is square root of that. So therefore, the closest point would be x is 5 halves and y is square root of 5 halves. Right? So that is the closest point on that graph to 3, 0. Right? That's it. I hope that this was clear.